Uh, Good afternoon, all. So we are in the sixth lecture of day two. Along with us, we have Professor Yang Unmin. He will be giving the lecture on catalytic converter, EGR, SCR, DPF, and other new emission control technologies. Hope this lecture will be beneficial and interesting for the participants. So over to you, sir.
Okay, thank you for your introductions. Okay, so good afternoon, everyone. Today, we're going to introduce a sixth lecture. Okay, let me go to the major changes faced by the human cans. The first one I want to introduce is the limited fossil fuel reserve. According to a report, the current fossil fuel can only sustain about another 50 years. Okay, if the fuel consumption increased by 2.4% annually, then the remaining fuel can only sustain another 50 years. However, if the fuel consumption increased by 5%, okay, by 5%, then okay, the the remaining fuel or the reserve can only sustain about another, oh, sorry, yeah, 2.4 can sustain about 70 years. However, if the fuel consumption increased by 5%, then the fuel reserve can only sustain about 50 years. Okay, so the first one is the limited fossil fuel reserve. Second major changes are global warming. Everyone is talking about the global warming, correct? So here we show the predicted temperature rise in the world. Okay, compared with 1960 to 1990, by 2070 to 2100, okay, the temperature rise will be range from 1 degree from 0 degrees C up to 8 degrees C. So we can see in some region the temperature rise is very huge. It's about 8 degrees C. For example, the North Pole, correct? And also in the North America, the temperature rise is also a few degrees C, not just 1 degree C. Okay, of course, some regions may be increased by 0.5, 0.6. So for different region, because the temperature rise is not uniform, it's not the same. Okay. So we can see because of the global warming, more and more extreme weathers occur in the world. For example, for example, in the different countries, we have the very strong turbulence and torrential, right? So all this kind of extreme weathers occurs more and more often. Yeah, in some countries, especially this year, okay, in some countries, the temperature is very high. It's the highest in terms of the history. It has the highest temperature in the summertime. And also we can see more and more farmlands have become deserts, and the sea level also is keep rising because of the melting of the icebergs, correct? So all these are some major changes faced by the humankind. Okay, so actually I also want to share with you guys some history. Maybe you guys don't know about this. In the 1952, actually there's a great smog in London. And yeah, in London, we know actually there's a very long history of fog in London, especially on December 5th, 1952. A very heavy smog descended on London, and this fog remains in place for 5 days, bringing the capital to a standstill. Okay, so what are the causes for this very serious smog? Okay, so do you think what is the major causes for this smog? Any comments or Yeah, please feel free to comment.
Dust particles and the water vapor in the air.
Okay, so actually in the 1950s, as we know, it's a few years after the Second World War, correct? So after the Second World War, yeah, the UK undergone a very long-term called industrial revolution. Okay, because yeah, the in order to increase the economy, so the industry is developing very fast in the UK, and a lot of power plants is built, and they produce a lot of noise, a lot of emissions, correct? And also the second major causes is the transportation. Okay, they produce a lot of vehicles, and as we know, the vehicles in that days, the vehicles produce a lot of smoke and other harmful emissions. Okay. Okay, in New York also has a similar history. For example, New York City experienced several major smog events in the 1950s and 1960s. For example, in 1953, the smog in November killed an estimate of 220 to 240 people. In 1963, the smog in January to February killed an estimate of 200 to 405 people. In 1966, the smog killed an estimate of 200 people. It is the most severe smog event in the city's history. Okay, actually similar smog days in other cities like Shanghai, Beijing, and also in some cities in India, for example, New Delhi, right? So have also this kind of smog days. Also are due to the industrial emissions, CO2 emissions, and transportation emissions, correct? Okay, so in order to mitigate gas emissions and global warming and greenhouse gas emissions, thereby more and more strict emission regulations have been implemented for various industrial and transportation systems, correct? Okay, so here we show you the contribution to CO2 emissions by different sectors. Okay, for example, about 42% of the CO2 contribution come from the electricity and the heat production. And about 21% of CO2 emissions was produced by manufacturing and construction. And about 22% of the CO2 emissions comes from the transportation system. And 6% of CO2 emissions is from the residential the buildings, and the other 9% from the another 9% from different sectors. Okay, if we look at the transportation system, then the transportation system, okay, the CO2 emissions can be further divided into different category. For example, the cars, the automobiles or cars contribute 40% of CO2 emissions. And the truck contribute 34% of CO2 emissions. Aviation, transportation contribute 11% of CO2 emissions, and marine transportation also contribute about 11% of CO2 emissions. And the railways contribute 4% of the CO2 emissions. So these are the major contributions of CO2 source. Okay, so how can we reduce the major emissions? Today, actually, I want to share with you guys about three different aspects can do. So first one is the engine modification. We can optimize the design of the engines, okay, and so that we can improve the efficiency and minimize the major emissions. Okay, so first one is engine modification. Second one is a post-processor. By using post-processing technologies, for example, DPF, the diesel particulate filters, and we have exhaust gas recognition and the SCR, correct? So all this can use to reduce the major emissions from the exhaust gas. And the third one is by optimize the design of the fuel. Actually, in the previous lectures, I have introduced a lot of this knowledge, correct? So we can optimize the design of the fuel. For example, we can minimize the atomic compositions, correct? Thereby we can reduce the CO soot emissions, correct? Okay, so now I want to introduce the post-processor technologies. Okay, so first one is a catalytic converter. Yeah, so first one is a two-way catalytic converter. Okay, this one was commonly used in the earlier 20th century. Okay, in the earlier 20th century. So the catalyst is both a two-way catalytic converter, mainly platinum, rhodium, or palladium. And this catalyst, with the presence of this catalyst, then the CO can be oxidized to form CO2. So the chemical reaction is a CO reaction reacts with the O2 to form CO2. And at the same time, the hydrocarbons, the unburnt and the partially burnt fuel also can be oxidized to produce CO2 and water. Okay, produce CO2 and water. Okay, so this is a two-way catalytic converter. It is used in the earliest stage of transportation system. However, okay, this kind of two-way catalytic converter is rarely used now. Okay, instead, it is replaced by this two-way catalytic converter. Okay, so this is a two-way catalytic converter. We can remove CO and hydrocarbons, and also can remove NOx emission. Okay, also can remove NOx emission. So here shows the chemical reactions occurs in the two-way converter. Okay, Okay, so since the oxidation of carbon, hydrocarbons, carbon monoxide is the same as the two-way catalytic converter. For example, carbon is oxidized to form CO2, and the CO is oxidized to form CO2. And the CH, the hydrocarbons, is converted into CO2 and the water, correct? So this one is the same as the two-way catalytic converter. And okay, so that's another additional function. Okay, this two-way catalytic converter also can convert NOx emissions into nitrogen. Okay, so now we can take a look at what happened. Firstly, the carbon will react with NO2 to form CO2 and NO. Then we can see CO will react with NO to form CO2 and nitrogen. And again, CO also will react with NO2 to form CO2 and nitrogen. And hydrogen also can react with NO to form water and nitrogen. Okay, so by using this two-way catalytic converter, also can convert the NOx emission NO, NO2 into nitrogen, CO2, and water. Okay. Okay, the next one I want to introduce is a diesel exhaust gas post-treatment. This one is more commonly used for the gasoline engines. And this one is used for the diesel exhaust gas post-treatment. Okay, so usually we have this three post-processor. Okay, so first one is a DOC, diesel oxidizing catalyst. Okay, this one actually so functions similar to the two-way catalytic converter, so can convert hydrocarbons and the carbon monoxide into CO2 and the water. Okay, so this one is the function for DOCs converts the CO and the hydrocarbons into CO2 and the water. Okay. Okay, then the second post-processor is a selective catalytic reduction, or SCR. Okay, or SCR. And for SCR to function, usually we inject urine into the exhaust gas here. The diesel exhaust gas, okay, the diesel exhaust gas, we inject urine. Okay, this urine can help to reduce the NOx emission. So sorry. So here we show you the chemical reactions in SCR. So we can see firstly, NO will react with NH3 ammonia. This with ammonia, and together with the oxygen, so can produce N2 and water. The second one is NO2, will react with ammonia and oxygen to produce nitrogen and water. The third one is the NO and NO2 and ammonia. Okay, the react to produce nitrogen and water. So SCR, the main function of SCR is to reduce the NOx emission, correct? Okay, the last one is the DPF, the diesel particulate filters. Okay, this one is used to remove the soot particles, the big size soot particles. Okay, the ultra fine soot particles cannot be tracked by the DPF, so will be discharged directly to the offsets. However, the medium size and the big size of soot particles will be tracked by this DPF, and then through the regeneration will be oxidized. Okay, through the regeneration will be oxidized. Okay, so by combining these three post-processor, we can remove most of the CO, hydrocarbons, and NOx emission and soot emissions. Okay. Okay, the next one I want to share with you is exhaust gas recognition. Okay, this one is commonly used for the diesel engines as well as gasoline engines to reduce the NOx emission. Okay, reduce the NOx emission. So the working principle is quite simple. From the exhaust gas, we can recycle maybe a few of the exhaust gas to the intake manifold, and then this exhaust gas will mix with the intake air and supply to the engine. So by this way, the fresh charge is dilute. Okay, the fresh charge is dilute, correct? Thereby, we can bring down the peak temperature, correct? Bring down the peak temperature, and also suppressing the formation of thermal NOx emissions, correct? So the principle is quite simple, okay? By recycle part of the exhaust gas and mix with the fresh charge, then we can dilute the fresh charge. Okay, as a result, the peak temperature of combustion process will be lowered. Okay, will be lowered, correct? And as we know, NOx emissions is a high combustion product, a high combustion temperature product, correct? So by bringing down the temperature, the NOx emission will reduce. Okay, will reduce. So this one is the working principle. Okay, so I have some questions for you. Firstly, why we can bring down the peak temperature? Okay, please feel free to comment. Why the peak temperature will be bring down by using the EGR?
Sir, the charge which is coming in is not completely new, no, sir. Some of the exhaust is also coming, so only some part of the charge which is coming in is
Yes.
combustible.
Yeah, correct. Yeah, very good. Okay. By dilutes the fresh charge. Okay, as we know, the exhaust gas, the major compositions are nitrogen, CO2, and water, correct? This kind of gas cannot be burnt. However, when increase the temperature, they will absorb heat energy. Okay, thereby bring down the temperature, correct? As a result, the peak temperature will drop. Okay, the second question is there any negative effects by using EGR for the engines for the gasoline engines or diesel engines? Is there any negative effects? We can bring down NOx emission, but is there any negative effects?
The power produced will be relatively less than normal.
Okay, great. Yeah, the power produced by the engine will drop. Any other negative effects?
Even there can be like accumulation of combustion, like the exhaust inside the cylinder, combustion chamber, inside the combustion chamber.
Okay, yeah. Also has other negative effects. For example, because the lower temperature, the CO and HC emissions will increase. Okay, CO and HC emissions will increase because the temperature drop. Okay, and also the overall efficiency also will drop. Overall efficiency will drop because of the EGR. Combustion process will deteriorate. Correct? Okay, so here we show you the reduced thermal efficiency, increased HCCO and emissions, and the reduced power. Just like one student has comments. Yeah, very good. Okay, so in addition to the post processor, there are also some other technology we can use to reduce the major emissions. For example, homogeneous charge compression ignition engines or HCCI engine, correct? So HCCI engines combines the advantage of conventional gasoline engines and diesel engines. And because before combustion process occurs, all the fuel and air will premix to form a combustible mixture, correct? So once ignited, the combustion process will be very fast. HCC engines can now work at higher combustion ratio. As a result, gas efficiency is about 30% higher than the gasoline engines. Okay. Again, ideally, the homogeneous HCC engines produce lesser emissions. For example, lesser NOx emission, and also lesser soot emissions. Okay, lesser NOx emission and lesser soot emissions. Okay, again, this is because before combustion process, the fuel has a premix with the air to form a combustible mixture. And this fuel air ratio is almost uniform in the whole combustion chamber. Okay? In the whole combustion chamber, the fuel air ratio is almost the same. Okay, so there's no region with a rich fuel, correct? And thereby the temperature, the peak temperature will be reduced. Okay, the peak temperature will be reduced. Okay, so for the HCC engines, the peak temperature usually is lesser than 1900 K. And under such low temperature conditions, the NOx emission will be very low. It's almost negligible. Okay, and also there's no impairment for the soot to form because the fuel air premix and form a uniform combustible mixture, right? So the soot emissions also is negligible. Okay, so for the HCC engines, the fuel can be natural gas, gasoline, methanol, ethanol, also can be even use diesel fuel. Okay. So here shows the comparison of our HCC engines with gasoline engines and diesel engines. First one is gasoline engines. So you can see for gasoline engines, actually the flame will start from the spark plug, and then the flame will transport from spark plug to the cylinder wall, correct? So during this transportation process, we can see between the combustion products and unburnt fuel admixture. So we can see here form a very high temperature zone. Okay, this one is a flame front. Okay, this one is a flame front. So this flame front has very high temperature. Okay, has very high temperature. So under these conditions, a lot of NOx emission will be produced. Okay, a lot of NOx emissions will be produced because the high temperature in this region. Okay, in this flame front. Okay, for these engines, okay, similar in this region, also produce very high temperature. Okay, produce very high temperature, and these engines will produce a lot of NOx emission and also produce soot emissions, because we know in this region, okay, the fuel ratio actually is usually is greater than 1. It's greater than 1, so it is partially oxidized and to form carbons. Okay, to form carbons and soot emissions. Okay, so last one is the HCC engines, because all the fuel are premixed with the air and form a combustible mixture. The fuel ratio is uniformly, okay, so distribution in the whole combustion chamber uniformly, correct? So there's no high temperature zone and there's no fuel rich zone, thereby case NOx emission and soot emissions will be very low or negligible. So this is all the advantage of HCCI engines. However, HCC engines also have some disadvantage. For example, it is easier to produce high cylinder peak pressure. Cases high cylinder peak pressure can damage the engine, correct? That's why HCC engine usually is working on the lean fuel combustion, lean fuel operating conditions. Okay, we cannot use too rich fuel in the engines, in the HCC engines. Otherwise, the peak cylinder pressure will be very high. Okay, this can damage the engine. Also, the second major change is auto ignition is difficult to control. So how to understand this auto ignition is difficult to control. Okay, because for HCC engines, these are compression ignition engines. Okay, compression ignition engines, which means once the temperature reaches the auto ignition temperature, then combustion process will start, correct? Okay. So if the fuel ratio is too rich, okay, so fuel ratio is too high, then the fuel combustion process will start earlier, which means that you cannot control the ignition timing at the correct timing, correct? So earlier combustion process, this morning we can introduce earlier combustion process can bring down the efficiency, correct? And also under the conditions, the peak pressure will be very high. Okay, so HCC engines can only working at partial load conditions and medium load conditions. Cannot work at higher engine load conditions. So the HCC engines has a smaller power range. Okay, smaller power range. Okay, so next one is the RCCI engines, reactivity controlled compression ignition engines. So in order to overcome the shortcoming faced by HCCI engines, a new engine design was proposed by the Ritz. Okay, Ritz is from Wisconsin. Okay, it's a professor from Wisconsin. So in this kind of engines, actually two types of fuel are used. When it's a low reactivity fuel, for example, use natural gas or gasoline fuel. Second one is a high reactivity fuel, for example, use diesel or biodiesel. Okay. So the low reactive fuel will be introduced into the engines through the intake manifold. Through the intake manifold is the same as the gasoline engines. And the high reactivity fuel will be injected into the engine directly by the so-called high pressure fuel injectors. Okay, so similar to the diesel engines. So it is more like a combination from gasoline engines and diesel engines, correct? We have low pressure fuel injection from the intake manifold, and also we have high pressure fuel injection from the high pressure injector, correct? So it is a combination of diesel fuel, diesel engines, and the gasoline engines. Okay.
Sir,
Okay. So here.
like, sir, what is the advantage of this, sir? Reactive control?
Okay. So yeah. So I want to show you the advantage. So you can see, firstly, the efficiency will be much higher. Okay. So here we show you the gasoline engines, the PV diagram for the gasoline engines. Okay. Let me use a laser pointer. Okay. This one, okay, is a PV diagram for the traditional gasoline engines. And this one is the PV diagram for the RCCI engines. So you can see for gasoline engines, the compression ratio usually is from 6 to 10, correct? However, for RCC engines, because of compression ignition engines, the compression ratio can be as high as 20, okay? So with a higher compression ratio, the efficiency will be much higher, correct? Like diesel engines, okay? Diesel engine has a much higher compression ratio, so diesel engines has a much higher efficiency than gasoline engines, correct? So the higher compression ratio means a higher efficiency, okay? So this one is the first advantage. The second one, okay, the oxygen engines, the emissions near zero, theoretically near zero. And the traditional gas engines produce NOx emissions, CO emission, correct? Okay, about 2 grams per kilowatt hour. But oxygen engines, the emissions will be close to zero. And also the soot emissions also is almost zero. Why? Again, because for this kind of oxygen engines, the main fuel is the main fuel actually is a no reactivity fuel. Okay, the main fuel. For example, we use natural gas. Also, we use natural gas and diesel fuel. About 80% to 90% of the fuel are natural gas. Okay, are natural gas. So this part of fuel will be supplied to the engine through the intake manifold, correct? So this fuel will go through the mixing process with the air. Before combustion process occur, okay, the fuel air are mixing very well already, correct? So the fuel air ratio are very uniform in the whole combustion chamber, correct? As a result, okay, there's no region for the engine to produce NOx emission and soot emissions, correct? Because all the fuel are evenly distributed in the whole combustion chamber, and the peak temperature will be lower than diesel engines and also lower than gasoline engines. Okay, so that's why this kind of engines has near zero NOx emission and also CO emissions and also soot emissions, almost zero soot emissions. Okay, because most of the fuel premixed with the air to form a combustible mixtures similar to the HCCI engines. Okay, for example, 80% or even 90% of the fuel are natural gas or gasoline, which are premixed with air to form a combustible mixture. Okay, so this part of fuel, the peak temperature will be low, correct? The peak temperature will be low. At the same time, the fuel air are evenly distributed in the whole combustion chamber. Okay, so there's no rich region, only in the spray. Okay, only in this position, we tend to produce NOx and soot emissions. But because this part of fuel is very small, only 10%, okay, on 10%, so the NOx emission and the soot emissions produced by this kind of engine is very, very little. Okay, and the efficiency can be increased, firstly, due to the higher control ratio, secondly, due to the fast combustion process, okay, the fast combustion process. Also can eliminate the after treatment system because the exhaust gas is almost zero, correct? So we don't need to employ this course after treatment system, like okay, like this kind of after treatment systems, okay, DOC, SCR, DPF, because we don't have this kind of exhaust gas, right? This kind of emissions, so we don't need to use a DOC, we don't need to use a SCR, and so also we don't need to use a DPF. Okay, so this one of course is the ideal conditions. Ideal conditions, we have this kind of advantage, high efficiency, near zero emissions. Okay, so is there any disadvantage for this kind of engines? You can guess first. Do you think is there any negative effects for the because of these engines?
Fuel injection becomes very complicated.
Okay, yeah, it's more complicated because we have two fuel supply systems, correct? Okay, very good. Any more?
Ultimately, the price of the vehicle
Mm-hmm. Okay, yeah, actually similar to HCCI engines because most of the fuel are premix, correct? Okay, so once ignited, the combustion process will be very fast. As a result, the peak pressure also will increase. Okay, the peak pressure will be very high. So this also has potential to damage the engine, correct? So for RCC engines, similar to the HCCI engine, the engine is only able to working at partial load conditions, okay, no load conditions to medium load conditions, cannot work at high engine load conditions, okay?
Sir, then can't we manufacture engines which are strong enough to withstand this high pressure, sir?
Yeah, you can design the engine stronger. Yeah, but even you design the engine stronger, for example, these engines, okay, because the pressure rise is too fast. The pressure, not only the peak pressure, and also the pressure rise is too fast. Is too fast. Okay, and also produce a pressure wave, so-called locking. Okay, as we introduced in the previous lectures as locking in gas engines. Okay, so similar to this RCC engines. Yeah, if the pressurized is too fast, okay, then also able to produce called the locking, and this can damage the engine. Yeah.
Okay.
Sir, in low temperature environment, cold start issues may be raised, sir.
Okay, yeah, RCC engines will be working at relatively lower engine speed, peak temperature condition, peak temperature. I mean the pressure rise is very high. In terms of, okay, we should understand, explain the difference between maybe the between the gas these engines and RCC engines in terms of the peak temperature and average temperature. Okay, in terms of average temperature, RCC engines has higher average temperature than the diesel engines because the combustion process is faster. Okay, so the average temperature is higher than that of these engines. However, for RCC engines, the temperature distribution is almost uniform, which means for the whole combustion chamber, the temperature can be as high as 1,900 K, for example. Correct? It is much higher than that for these engines. Okay, for these engines, the average temperature, even as the highest value, the average temperature is only about 1,600 K, about 1,600 K. However, the peak temperature is much higher. in this region, the temperature can be as high as 2,800 K. Okay, so the temperature for these engines, the temperature is not uniform. Some region has very high temperature, some region has a very low temperature. Okay, so yeah, this one is different from the HCC engines and RCC engines. RCC engines, the average temperature is higher than that of these engines. However, the peak temperature is much lower.
Sir, are these engines used in like normal daily use automobiles now? Are they in production?
Sorry?
Are these engines are in production, sir? Is any company using these engines?
Okay. Currently, actually, yeah. Since research has been conducted by many researchers. However, since technology is not mature at this moment, okay. Yeah, some companies are investigate or design. They have conduct some testing. However, yes, also face some challenges. For example, yes, this one I can mention here, higher cylinder peak pressure, and can only work at lower or medium engine load conditions. Okay, so the power range is limited compared with diesel engines. Okay, that's why. Okay, this technology actually is not mature yet.
Okay, sir.
And also higher because for us engines, usually they also need to use a higher EGR ratio. This one can also promote the formation for HC and the CO emissions. Okay, theoretically, yeah, it's near zero. However, because of the employment of EGR, so the HC and CO emissions will be increased. Okay, so there's no any single technology, yeah, which can totally eliminate all the emissions actually. Okay.
Sir, actually, I want to ask a question, sir.
Sorry.
Sir, I want to ask a question, sir. Hello.
Yeah.
Sir, actually, the as you said, sir, in disadvantage, the HCCI engine has higher compression ratio, sir. So higher compression ratio is also in diesel engine, sir. What is the disadvantage then, sir?
Okay. RCC engines actually the compression ratio is similar to the diesel engines, but higher than gasoline engine. Okay. Yeah. Still. Yeah. The compression ratio usually is still from 16 up to 20. It's similar to diesel engines. The compression ratio, not higher than diesel engines, but higher than gasoline engines.
Right, sir. Means sir, yes, sir. Means in petrol engine the compression ratio is less as compared to diesel engine. But sir, there is means is there any problem in sir getting high compression ratio, sir? In we can put gasoline in the diesel engine also, sir, by doing some modifications and all.
Okay. So you mean can increasing the compression ratio for gasoline engines, thereby increase the efficiency, correct?
Right, sir.
Okay. Yeah. Good idea. Yeah, but do you think, yeah, for gas engines, okay, gas engines is the ignition timing is controlled by the spark plug, correct?
Right, sir.
Yeah. Okay. So if we increase the compression ratio, then what happens? Before you use the spark plug to ignite the fuel admixture, because the higher compression ratio, before you use the spark plug, the temperature will be higher than the auto ignition temperature of gasoline already. Okay, then you cannot control the ignition timing, which means, okay, that's why for gas engines, the compression ratio cannot be too high. Okay, so the first reason. Okay, second one, gas engines, okay, are designs usually is thinner and light compared with diesel engines, correct? So gas engines also cannot sustain too high pressure. Okay,
Sir,
so the peak
sir,
pressure is limited by the by the engine, the materials, is the cylinder wall is too thin, cannot sustain too much pressure.
Sir,
Okay.
you said that we cannot control the timing of we used to control the timing by help of the spark plug. By introducing one injector, like in diesel engine, sir, we can control the timing, sir. When the spark we will be supplying the fuel gasoline by the help of injector only, sir.
Okay, yeah, diesel engines is controlled by the ignition timing. It's controlled by the fuel injection timing, correct? Because we use diesel fuel injected by the high pressure fuel injectors. Okay, so if you want to retard the ignition timing, you can retard the fuel injection timing, correct? So diesel engines is easier to control. However, gas engines is introduced into the engine through the intake manifold. So it is a premix with the air already to form a combustible mixture, correct? So once the temperature reaches or the ignition temperature of the gasoline, then the gasoline will start ignition, correct? Start combustion process. So that's why for gas engines it cannot control. However, last class actually I introduced GDI, gasoline direct injection, correct? So gasoline direct injection actually is copies the idea of diesel engines. Okay, because for gasoline direct injection, you can control the gasoline injection timing, thereby you can control the ignition timing, correct? Okay, so GDI, the gasoline direct injection engines, actually its efficiency has been increased to more than 40% already. Okay, but here we just compare the conventional gas engines, not the GDI engine. Okay, any more question?
Sir, continue, sir. They may ask question after the presentation. Okay, sir.
Okay, so I think let me. Okay, so the next one, we spend about 5 minutes to finish this lecture. Okay, so the next one is echo-based actives on the major emissions of these engines. So basically, we have investigates 3 different actives echo fuels. So first one is butanol, second one is ethanol, and the third one is octanol. Okay, so firstly, it compares nitrogen, gets NOx emission, and also compares the HC emissions. So actually, we cannot see any obvious trends on the NOx emission. It's more or less quite similar. Some of the blend fuel has higher NOx emission, but some of them has lower NOx emission. So there's no any obvious trends. And for the HC emissions, also actually some of the fuel has a lower HC emissions, some of the fuel has higher emissions. We cannot also get linear conclusions. Okay. However, for the soot emissions, if you compare this one, diesel 18 and the butanol 20. Okay, so D80, B20, and D80 and the O20, and this one D18 and the E20. Compare these 3 types of fuel. Okay, this one, and this one, and this one. Okay, so this 3 types of blend fuel contains 80% diesel and 20% fuel additives. Okay, but with different carbon chain lengths. Okay, ethanol is the shortest one, followed by butanol, and octanol has the longest carbon chains. Right? So compares its impact on the soot emissions. Also, soot emissions we can see. Okay, this one is diesel fuel is 100% diesel fuel soot particles. Okay, then this one reduce 23%, correct? Only 77%. And this one is 82%, and this one 47%. Okay, so we can see this one is ethanol, 20% ethanol, correct? So we can reduce the soot emissions by 53%. Second one is this one. This one is butanol, 20% butanol. So can reduce the soot emissions by 23%. And this one is octanol, 20% octanol. So can reduce the soot emissions by 18%. Okay, so you can see butanol is the shortest one, and ethanol is the shortest one, and the octanol is the longest one. Correct? So you can see the shorter the carbon chain length, then the reduction of the soot emissions is the biggest one. Correct? So you can get some conclusions. Okay, so next one is a few actives on the performance of the engine, especially on the major emissions. Okay, I want to introduce 1,4 dioxin. Okay, so 1,4 dioxin is an ether-based oxygenated active. It is able to improve the C10 number, increase the C10 number. Okay, so compares the CO emissions of diesel fuel and biodiesel. And the other two fuels contains 5%, 5 milliliters and 10 milliliters of our 1,4 dioxin. Okay, so you can see compared with the diesel fuel, okay, with this fuel additives, the CO emissions will be decreased. Similarly, HC emissions also will be decreased. Okay, will be decreased. And the smoke density as well as the NOx emissions, all these emissions will drop compared with the diesel fuel, right? Okay, of course, there are some other potential way can control the emissions. For example, optimize the fuel properties. Okay, this one we can introduce in the previous lectures, so I don't want to repeat anymore. And also can increase the C10 number by using the 1,4 dioxin, correct? And also there are some other fuel additives can increase the C10 number. And also we can use the emulsion fuel. Okay, this one we can introduce in the next class. And also can use a supplemental gas injection. These two also we are going to introduce in the next class. And also can optimize fuel injection strategy. This one also had introduced in the previous class already, right? So that's the end of this lectures. Any questions?
Yeah, participants, you are now open for any question. If you have any doubt, you can ask Professor. Sir, yeah, hello.
Yes, sir.
Hello.
Am I audible?
Minmay, yeah, you can ask question.
Sir, actually, you discussed about the EGR, sir. EGR is
EGR.
yes, sir. EGR, exhaust gas recirculation means I understood that yes, some part of the emission, some part of the exhaust gas has been circulated to the inlet manifold to reduce the temperature of the cylinder. But sir, with the EGR, so with the exhaust gas also, some particulate matters also come. Soot gas, that is called soot gas. So that also get entered into the combustion chamber, and that makes that carbon formation in the exhaust valve, EGR system itself only, EGR valves also. So that's cost much more as compared to this and all, sir. Is there any other solutions? Any type of other filtration that we can do to reduce, to remove that soot mass?
Remove the soot emissions. I mean, by using EGR produce more soot emissions. You mean is there any way we can reduce the soot emissions? Is that your question?
Sir, my question is, sir, in EGR, sir, that all the carbon deposits also get deposited at the inlet valve because of the EGR only, sir. Means exhaust gas contain carbon soot particles. That particles get trapped in the valve, sir.
Okay.
Get choked.
Okay, understand. Okay. Yeah, so for EGR, usually the there should be descent in the cooling, which means that the exhaust gas will be cooled down first and before supplied to the intake manifold. It is not directly supplied to the recycle and supplied to the intake manifold. Exhaust gas because it has very high temperature, right? So if directly premix with the fresh air, then what happens? Will increase the temperature of fresh charge, correct? And the density will drop. This one cannot bring down the density of the fresh charge, and the nicer fresh charge will be supplied to the engine. So under the conditions, then the power produced by the engine will be significantly drop. So the EGR, for EGR, usually will go through, the exhaust gas will go through the intercooling system. After cool down, again, some of the particles actually will be absorbed by the cooling system. Actually, the exhaust, the soot particles containing the exhaust gas is not so much. Okay, it's not so much. It's very small in terms of absolute value. Okay, it's not as much as you think. Okay.
Yes, sir.
Okay, any more questions?
Sir, in RCCI engines, sir, what are the thermal efficiency limitations in low load conditions?
What is the limitation for what?
So limitations for the low load conditions, sir, in
Oh,
RCCI
okay.
engines.
Yeah, of course. Yeah. Okay. For us engines, yes, there's also no limitation. Because if the fuel aeration is too lean, okay, the fuel aeration is too low, or the fuel is too lean. So under the conditions, combustion process cannot start successfully. Okay, if too lean, then the combustion process cannot start successfully. So cannot be too lean. Okay, because in the oxygen engines, most of the fuel are more reactivity fuel, like gasoline, like natural gas, correct? It is not easier to ignite it itself, correct? So if too lean, then the ignition will become more challenging, more difficult. Okay, so that's why for the oxygen engines, the fuel, the no conditions cannot be too lean. Yeah, so the best way, okay, for the oxygen engines is working at the medium engine load conditions. Okay, that's why for oxygen engines also the power range is narrow.
Okay, sir.
Okay, any more questions? Okay, tomorrow I will share with you guys the latest research in our group. Okay, so the first time we have proposed a revolutionary strategy to achieve net zero greenhouse gas emissions. Okay, so tomorrow we can also discuss more now. Okay, if you have a question. So today we'll stop here.
Okay, sir. Thank you very much for the presentations today. Today we have heard 3 lectures from you along with the tutorials. This might be a little bit hectic for you today. I hope the participants have enjoyed also the lectures. And with this note, we are closing today. Tomorrow we'll have again 3 lectures and 1 tutorial. Out of the 3 lectures will be delivered by Wenmin sir, and I will deliver 1 tutorial. Thank you, sir.
Yes, thank you. See you tomorrow.
See you, sir.